Okay, so let's go over this assignment from yesterday. We might do it in two parts. We might just push through, we'll see. So I'm just going to show you, it says do these 1 to 8 without a calculator. So what I did was I took the time and I wrote my perfect squares and my perfect cubes along the top, because I'm going to show you two different ways. Just remember, there's lots of times in math where there's more than one way to do a question, and it's going to be whichever way makes the most sense to you. So what we're focusing on is we are taking, remember we call this an entire radical because the entire thing is underneath the radical sign, and we're going to write it in simplest form, which really means write it as a mixed radical. That's what that means. So you just got to get comfortable with the language. So two ways to do this. We can first of all, because it's a square root, right? That's implied there, that 2. It's like an invisible 2. Okay, we can take a look at our list of square roots. Up here we can think to ourselves, what is the biggest perfect square that divides evenly into 108? Okay, and for ease here, I'm going to tell you it's 36. So really what happens is square root of 108 actually turns into the square root of 36 times 3. So that's one way to do that. And then you can think, I know what the square root of 36 is. It's 6. And what's left over under the radical sign? 3. So the answer is actually 6 root 3. It is B. Another way you can do this, okay, that's one simple way to do it. Sometimes when we're working with bigger numbers, though, we just don't know right away which is the biggest perfect square that goes in there. So you could do with what you know, and that is in your wheelhouse, and that is to make a factor ladder or factor tree. 54 divided by 2 is 27. 27 is now divisible by 3, which is 9. 9 is divisible by 3, which is 3. And lastly, remember, we always have to end with 1. Here are our prime factors. Because it's a square root, we're looking for numbers to show up in groups of 2. Here is a group. I'm just going to use a different color. And here's another group of 2. So 2 times 3 is 6. What's left over? 3. And we put that under the root sign. So we're going to get exactly the same answer. Okay, 6 root 3. Just a different way to do that. Okay. Well, now here we go. We got a cube root of 80. This is an entire radical because there's no coefficient or multiplier out front, right? Remember that that's called an index. So we're looking for numbers that are showing up in groups of 3, or what we can do is we can go up here, we can say, what's the biggest perfect cube that goes into 80, okay? And we're never going to count 1. So 8 will go in there. If we pick 27, we know if we go 27 times 2, that's going to be 54. 27 times 3, that's going to be bigger than 80. So the biggest perfect cube that actually goes into 108 is 8. Or I'm sorry, 80. Okay, so we know it's going to look like this. The cube root of 8 times, and then it's 10. What's the cube root of 8? It is 2. We never change the index. What's left over? The 10. Okay, so we know that the answer is going to be 2 cube root 10. That's this answer right here. Okay, another way we can do this is to say, I'm going to take 80 and I'm going to divide it by 2. 40 divided by 2. 20 divided by 2. 10 divided by 2. And lastly, 5 divided by 5, which is 1. Now, because the index tells us it's a 3, we're looking for numbers to show up in groups of 3, and here we go. So I took out a 2, that became my coefficient or my multiplier. Here it is. Keep the index the same, draw the radical sign, and the radicand is anything that's left over. 2 times 5 is 10. How can I check my work? 2 cubed is 8. 8 times 10 is 80. That's how I can get back and check my work. All right, so now here we go. Now we're going to write 6 root 5 as an entire radical. Okay, so we remember that the index here is 2. It's invisible. So the way you can think about this is go like this. 6 squared is 36, and 36 times 5. Okay, and feel free to use a calculator if you want to. 36 times 5 is 180. We have to remember to write it under the root sign. Answer there should be C. Do exactly the same thing here now. Okay, 3 fourth root 2. So we're going to take 3 and raise it to the exponent 4. And you get 81. And 81 times 2 is anyone, 162. And we have to remember, We have to write it under the radical sign, and we have to remember to keep the index the same as it was in the mixed radical form. So our answer here would also be C. Okay, we're gonna do the same thing now. We're gonna do the reverse actually. Now we're gonna take 160 and we're gonna write it in simplest form. Now here's where I think it's important that we remember how to do this, because I don't know my fourths, and so I don't know what the biggest fourth is that goes into 160. But in my wheelhouse, in my bag of tricks, I'm sorry, that's my oven going off too, by the way. I'm trying to multitask here. Okay, 20 divided by 2 is 10. 10 divided by 2 is 5, and 5 divided by 5 is 1. So we're done. Here's our list of prime factors, and now because we had a fourth root, we're looking for numbers to show up in groups of 4. Here we go. We got 4 2's here. So that group of 4 2's, pull out a 2, that becomes my coefficient or multiplier. You'll hear those used interchangeably. I'm going to write my index in. That's important that I keep that accurate, same as what we started with. And then I look, what's left over in this list of prime factors? 2 times 5, which is 10. 2 fourth root 10. Let's see if that's an option, and it is. Okay, letter A right there. All right, so I'm going to stop there. We're halfway through the assignment. And then I'm going to start the other side so that I can upload this video. Okay, I hope that you found that helpful. I know it's hard, like not being right in the classroom.